Hello, welcome to the module 33 of symbolic logic course, and now embarked on understanding this categorical logic or Aristotelian logic. So, we were talking about this standard form categorical propositions for in the last module, but time has come now to look at them more closely. We have just barely gotten introduced to them. So, now it is time to understand what is going on inside them, and we will also learn about something called the traditional square proposition, which holds a very important place in Aristotle's logic. And then based on this traditional square proposition, I will show you how immediate inferences can be done in the Aristotelian system. So, this is what we will learn in the module 33 today. See, first we need to go back to the rationale, the reason why we left propositional logic. I have already mentioned this, but still nonetheless it is better to bring it back again, that remember in propositional logic our basic unit or ultimate unit was the structurally simple proposition, right. Now, in categorical logic we have gone beyond that. Beyond in the sense that we have gone inside the structurally simple proposition. So, now what we are doing, we are analyzing them using what? Using the class inclusion lens, class relationship lens. Either there is a relationship or there is none. Somehow we are using this to probe into the structurally simple propositions. So, otherwise what seemed to be completely inaccessible earlier, for example, if you had all A's are B's standing as a structurally simple proposition, say in your propositional logic time, then this is it. You would be simply assigning it a capital letter, that is about it. But what we are doing, we are using the lens of class inclusion, class membership, to look inside this kind of propositions. And what we are trying to, what we have found, that what they do when we are looking through this class inclusion, that we see a distinct relationship. What is that relationship? We are seeing that all of A is included in B. What does that mean? It means that if A is a class, then every member of the class A is included in the class B. Right. So, all members of A class are also members of the B class. Now, that is an information that we are getting through this kind of opening up of the categorical proposition. So, we have gone inside the structurally simple proposition to open them up and further analyze them to find out what is the logical information given inside them. Now, that we have started. So, and we have used the Venn diagram and other things to see those relationships, to capture those relationships. But now, here comes something more. In Aristotle's logic itself, there is a mechanism to conduct immediate inferences from each other, provided when the subject term and the predicate terms are identical. So, if you line up A, E, I, O propositions in standard form, when their subject term and predicate terms match, right. So, when they have exactly the same subject and predicate term, you can line them up in a certain sort of a way. I have taken some examples here. All Indians are Asians, no Indians are Asians, some Indians are Asians, some Indians are not Asians. This is A, E, I, O. When you have such foursome, then categorical logic represents the internal relationships among these in terms of a square of opposition. I will show you in a second. The square is indeed a square, it is a figure, and the opposition here would mean the logical differences. So, basically what it allows us to enjoy is the logical differences among these propositions when they have the same subject term and the predicate term. So, let us take a look into this square up opposition. I told you that this is a traditional component in Aristotle's logic. So, we have preserved it as is from Aristotle's times. So, take a look. So, here is what is known as the square of opposition, the traditional square of opposition. For your sake, I mean, this does not look like a square, perhaps it looks more like a rectangle, but given that also, I mean, you can see what we have done is to line up this A, E on top, I and O at the bottom. All right. So, remember these A, E, I, O's have exactly matching subject terms and predicate terms. When that happens, the square of opposition tells us that these are the kind of logical differences or oppositions you can see them in them. I will explain that later. Let us now first get acquainted with the name of the relationships that they have. So, between A and E, there is a relationship of contrary, C-O-N-T-R-A-R-Y, and the pairs are called the contraries. Okay? So, between A and E, contrary relationship holds. Look at the bottom of the square. There is I and there is O. The relationship between them is sub-contrary. The pair is called the sub-contraries. All right. So, this is contrary relationship, this is sub-contrary relationship. Now, let us take a look at the side of the square. You have A and I, E and O. The relationship that flows on the sides is called subalternation, subalternation. All right. So, this is on between these two pairs, and then inside, as you can see, between A and O and E and I, the relationship is called contradiction. Okay. So, this is the picture, this is what we would call the traditional square up opposition. I have taken actual examples to show, so that we understand this better. This is, suppose instead of schematic A, E, I, O, we put actual categorical propositions here. Maybe it might help you to understand it better. So, here for example, all Indians are vegetarians, no Indians are vegetarians, some Indians are vegetarians, some Indians are not vegetarians. You can choose your own A, E, I, O, okay, and form this square up opposition to understand how these relations work. But keep this picture in front of you and mull over what I am going to say now. So, I am going to now explain what each of these relationships are, but you need to remember which two pairs we are talking about and how they actually fit into this description. All right. So, we will refer back to this picture, but let me just move it here a little. So, what we are talking about is that on the basis of the traditional square up opposition, which is this, we can form some immediate inferences. So, given one premise, you can jump into a conclusion. All right. Immediate means there is no other proposition in between. In between what? In between the premise and the conclusion. So, directly you can go, immediately you can make some inferences, provided you have this kind of lineup of A, E, I, O with same subject and predicate terms. The first relationship, which is between A, O and E, I, is called the contradictory. The contradictory. Between, as you can see, this is A, O and E, I, right. Between this, you can see the quality differs. If one is affirmative, the other one is negative, right, and the quantity also differ. If one is universal, the other one is particular. So, A and O, quality, quantity differ. E and I, quality and quantity differ, and that is the nature of this relationship called contradictories. What follows from that, that exactly one of them can be true at one time and exactly one can be false. Get me? So, if you know one of them is true, you can immediately infer what? The other one must be false, right? Or if you have the information that one of them is false between these two pairs, you know the corresponding contradictory will have to be true. Get it? So, this is going to be the basis of some immediate inferences. We will see examples, but I hope you got it. So, we are talking about the AO and EI, and these two pairs are known as the contradictories in this kind of sense. It only means quantity and quality both differ. Then comes the contraries. Let us take a look. Who are the contraries? The contraries, if you remember, on top of the square of the opposition, we had A and E. A and E. Let us bring the picture back. So, these are the contraries. You have the A and the E as contraries. The I and E are, I and O are sub-contraries. We will come there later. But first the contraries. Notice that among the contraries, the quantity is the same. Between A and E, both are universals, right? So, quantity is the same. What is different is the quality. If one is affirmative, the other one is negative. But notice that their relationship is different from the contradiction, because they both cannot be true. Okay? That matches with the contradiction. Exactly one of them can be true. Both of them cannot be true at the same time. So, if one of them is true, you know the other one must be false. But unlike the contradictories, both may be false. All right? So, if you know that some Indians are vegetarians, then it is neither true that all Indians are vegetarians, nor is it true no Indians are vegetarians, isn't it? So, both may be false, both may be false, which you do not have in case of the contradictories. So, both may be false, and this is the nature of the contraries. Quantity same, quality different, but both may be false, though both may not be true at the same time. This is your contraries. Let us take a look into the other relationships. So, here is what we would call the sub-contraries. Sub-contraries, remember, between I and O. I and O. And here also what happens is the quantity is the same. Quantity is the same, as in both are particular. Only the quality is different. Now, here, though it seems like a version of contrary, there is a difference between the contrary and the sub-contrary. What is that? Both cannot be false. Remember, in sub-contrary, both could be false, but sub-contraries, because both are particular, you cannot have in Aristotelian system that both are false. That is, you cannot have, say, some Indians are vegetarians is false, some Indians are not vegetarians, that is also false. Okay? The Aristotelian scheme at least will not allow. So, both cannot be false, though both may be true. It may be true that some Indians are vegetarians, it may be also true that some Indians are not vegetarians. True? So, this is the peculiar nature of sub-contraries. So, what happens is that when you know of this pair, one of them is false, you can easily assume the other one must be true, right? But if you know one of them is true, nothing follows, right? It is not necessary the other one is true, you just know that there is a possibility the other one might be true. So, from just by knowing that one of the I and O pair is true, nothing concrete follows, okay, about the the corollary. You cannot infer anything definite about the other. Then comes what is known as the side relationships. Remember subalternation, and we are talking about the AI and E and the corresponding O. So, there is a relationship. You have the same A and its corresponding I, you have the E and its corresponding O, and the relationship is called subalternation. What happens here? The only difference is there in quantity, right? So, between A and I, you know that they are both affirmative, quality no difference. E and I, no difference in quality, both are negative, but one is universal, the other one is particular. So, quantity difference is there in subalternation. When that happens, the truth, we say, flow from the universal down. That is, if you know that the universal is true, you can assume or infer that the corresponding particular must be true. Okay. So, whether it's A, whether it's E, you know the corresponding particular must be true. On the other hand, the falsity climbs up, meaning what? That if you know the particular is false, the corresponding universal must be false, right. So, if you know that the I is false, for example, that it is false that some Indians are vegetarians, you can infer from it, it must be false also that all Indians are vegetarians. Okay. So, this is the nature of subalternation. So, the pairs are A I, E O, and as I said that they differ in quantity, and truth flows down and falsity climbs up, if you remember that. So, once more we are going to visit the square of opposition and then use this relationship to form some immediate inferences out of this. So, contraries between AE, subcontraries, subalternation on the sides, and diagonally present is the contradiction relationship. And I have explained to you how these work, how the pairs are connected, and what kind of truth value inferences you can make based on these relations. So, that is what we are going to try, this immediate inferences from this. So, sit down with a piece of paper and try to solve as we go along. That suppose I tell you, you choose your own AEIO, but with exactly matching subject and predicate terms for you to understand this. Now, suppose I tell you that the A is true. Suppose I tell you that your A is true. What can you tell me about the truth value of the corresponding E, I and O? Did you understand the question? If I tell you that your A is true, what can you tell me about the truth values of the corresponding E, I and O based on what you know about the square of opposition? Okay. So, immediately I can see that some of you will say, but O has to be false. Why? Because we know that O is false by contradiction. And once more, remember contrary, both cannot be true. So, if A is true, the corresponding E will have to be false. Remember subalternation, truth flows down. So, if A is true, the corresponding I has to be true. Now, see, you have just figured out that you have made some inferences about them and you have determined their truth values. Did you do any truth table? Did you do any truth trees? Did you just do some calculation to do that? No. What you did was to utilize what you know about the square of opposition, right. So, similarly, you can go and talk about what if the E is true, and then you know that similarly this will be the truth values of the corresponding A, I and O's. Suppose I tell you that I is true, what happens to the corresponding A, E, O? Easiest probably is that E is false based on the contradiction. That is the nature of the contradiction. But if I is true, please note that you do not know anything about, surely you do not know anything of necessity, what is going to be the truth value of the corresponding A. It is not necessary that the A will be true, right, but that does not mean the A is necessarily false. So, the best answer here is the value of A is undetermined. We just don't know, we can't be sure. Similarly, remember, I is true both in sub-contrary, both may be true, not must be true, right? So, you don't know whether O is true, you don't know that, but if you don't know that, that doesn't mean O is false, does it? So, it doesn't. Therefore, the best answer here is that O will be undetermined. So, same thing will happen when you say O is true. As you can see, what we have generated are many immediate inferences about the truth values of the corresponding ones. So, if this is with true, what happens with when one of them is true? Similar thing we can do with falsity also. Suppose I tell you A is false, then what happens to the O, E and I? If A is false, you know immediately O has to be true. Why? Because of contradiction. But if A is false, do we know what the truth value of the E would be? No, because both may be false. Maybe does not mean must be. So, you do not know that E must be false. You also do not know that E must be true. So, the best answer here is E is undetermined. Similarly, you know that the universal is false. What happens to the corresponding particular? Subalternation says we don't know. A is false does not mean the corresponding I will be false. It does not mean that it will be true either. So, you go with this, I is undetermined. Same thing follows with E is false. I suggest that you sit down with this lecture and try to think. This is why I said write on a piece of paper your own set of AEIO to understand these immediate inferences and work it inside your mind. It is very intuitive, but at the same time you need to realize the truth of what we are saying here, right. So, you need some practice. What if I tell you that I is false? I is false means E is true, that is for sure by contradiction. But if I is false, then you know O has to be true sub-contrary, because both cannot be false at the same time. So, I must be, O must be true. If I is false, then we know A is false. How? By subalternation, falsity climbs up, and same result you can see also almost similar result in with the case of falsity of O. What we just did, as I was saying, is immediate inferences based on square opposition. So, square opposition we have learned, and as I told you, it has a pivotal place in Aristotle's logic, and as you saw, this becomes the backbone for making immediate inferences about other related and relevant categorical propositions. Now, this does not mean that this is the only kind of immediate inferences available in categorical logic. There are three other kinds. There is conversion, there is obversion, there is contraposition, and each one is a method for immediate inferences. So, given a premise, you can do these operations on them to get a result. That would be a valid conclusion, and where they will tell you where it is valid, where it is not, and so on. But we shall not discuss this here. So, because of paucity of time and because it's an online course where we have to maintain other constraints, so we are not going to discuss any of this, but if you are interested you can take a look into this. But what I taught today is how to do immediate inferences based on square opposition, and with the knowledge of the square opposition, in fact you can jump into many such inferences. Okay. So, this is where we are going to stop today, and there will be more in the next module, but I hope this is so far is all right. Keep up the good work of practicing on what we have discussed and drawing this square opposition to have a feel of this. All right. Thank you very much.